In this video, we're going to talk about how to solve a homogeneous differential equation. So let's start with this example. 2x dy is equal to x plus y times dx. So how can we solve this homogeneous differential equation? And what makes it a homogeneous differential equation? Notice that every term has the same degree, and that is, it's all in the first degree. In order for it to be a homogeneous differential equation, the degree has to be the same for each term. It could be 2, it could be 3, but it just all has to be the same. Now, whenever you have this situation, what you want to do is replace y with v times x. And at the same time, you need to differentiate this function using the product rule. The derivative of y is dy. And to differentiate vx, you need to differentiate the first part. The derivative of v is dv, and then times x. And then now we need to differentiate the second part, keeping the first part the same. So the derivative of x is dx. So we can say that dy is x dv plus v dx. So let's replace dy with this expression, and at the same time, let's replace y with v times x. So this is going to be 2x times x dv plus v dx, and that's equal to x plus vx times dx. So now what we need to do is simplify. For now, I'm going to leave the left side the same. There's no need to change it at this instant. Now the right side, I can factor out an x. So I'm going to have 1 plus v times dx left over. And so I could divide both sides by x or just cancel the x variable. And now I'm going to distribute this 2 to everything inside here. So it's going to be 2x dv plus 2v dx. On the right side, I'm going to distribute dx to 1 plus v. So it's going to be 1 times dx, which is dx, and then plus v dx. So notice that these two terms are similar. We have a 1 in front of this term. So I'm going to subtract both sides by 1 times v dx. And so this will cancel. And now I have 2x dv. 2 minus 1 is 1, so plus 1 v dx, or simply vx, and that's equal to dx. Now I'm going to take this term, move it to the other side. So we have 2x dv, and that's equal to dx minus v dx. Now on the right side, I'm going to factor out dx. So it's going to be 1 minus v times dx. So what I'm going to do at this point, let me just rewrite this equation at the top. I need to separate the variables. So how can I do that? How can I separate x from v? At this point, you need to divide both sides by 2x and also simultaneously by 1 minus v. So on the right side, the 1 minus v term will cancel, and on the left side, 2x will cancel. So on the left, I have 1 over 1 minus v times dv, and on the right, 1 over 2x dx. So now I can integrate both sides. So on the left, I have the integral of 1 minus v dv. On the right, I'm going to take out the 1/2, put it in front of the integral symbol. So I have 1/2 the integral of 1 over x dx. So what is the antiderivative of 1 over 1 minus v? And what is the antiderivative of 1 over x? The antiderivative of 1 over x is ln x. And the antiderivative of 1 over 1 minus v is ln 1 minus v. But if you take the derivative of 1 minus v, that will give you negative 1. So we need to put the negative in front. And then on the right side, I'm going to add the constant c. So this is what we now have. Now, we need to clean up our solution. So what do you think we need to do? This negative sign, you can view it as the negative 1 in front of the natural log expression. And the property of logs allows us to take the coefficient and move it to the exponent position. So this is ln 1 minus v raised to the minus 1. And I'm going to do the same thing with the 1/2 constant. So this is going to be ln. Right now it's an absolute value of x. And then it's going to be square root x, or x to the 1/2, which I'll leave it as x to the 1/2 for now. Now c, I'm going to put a natural log in front of it. ln c and c, they're both constants. So I can just make it natural log of c. It's still a constant. If I differentiate c or ln c, the result will still be the same. It will give me 0. So this doesn't change the answer. Now, 1 minus v raised to the minus 1 is the same as 1 over 1 minus v. And on the right side, we have the natural log of the square root of x plus ln c. Now, we need to condense those two logs into a single log. For instance, ln a plus ln b can be written as ln a times b. So ln square root x plus ln c, we can write that as ln c times the square root of x. And on the left side, it's just going to stay the same for now. So because we have a natural log expression on both sides of the equation and nothing else, we could set the inside of the natural log expression equal to each other. So therefore, we could say that 1 over 1 minus v is equal to c times the square root of x. Now recall that we said y is equal to vx. So v is y over x. At this point, replace v with y over x. Because the original equation only had y and x. V was just a means to help us differentiate, or rather, not differentiate, but integrate the differential equation. Now, to simplify this complex fraction, I'm going to multiply the top and the bottom by x. So on the left, I have x divided by, let's see, 1 times x is x, and then x times y over x, these will cancel, leaving behind negative y. And this is equal to c times the square root of x. Next, I'm going to multiply both sides by x minus y. And so these will cancel. And now I'm left with x times c square root x, x minus y. Now at this point, what you want to do is square both sides. So you have x squared on the left, c squared. The square root of x squared is just x, and then x minus y squared. Now let's divide both sides by x. So these will cancel. On the left side, x squared over x is just x. Now, c squared and c, they're both constants. The derivative of c squared and the derivative of c is still 0. So instead of writing c squared, you can simply leave it as c. Just some generic constant. So right now we have x is equal to c times x minus y squared. The final answer for this problem is as follows. The absolute value of x is equal to c times x minus y squared. So this is the final answer. So that's the solution to the homogeneous differential equation. Now let's work on another example. So let's say if we have this problem, y prime is equal to xy divided by x squared minus y squared. So go ahead and solve this homogeneous differential equation. And the reason why it's homogeneous is because every term has the same degree. This term is degree 2, and that's degree 2, and then 1 plus 1 is 2. So the first thing we're going to do is replace y prime with dy divided by dx. And then we're going to put this in the appropriate form. So I'm going to cross multiply everything. So I have xy times dx, and then that's equal to dy times x squared minus y squared. And so now that it's in this form, I'm going to replace y with v times x. And just like before, we know that dy is the derivative of vx using the product rule. The derivative of v is dv, so we're going to have x dv. And the derivative of x is dx, so v times dx. So everywhere we see a y, we're going to replace it with v times x. And we're going to replace dy with x dv plus v dx. So this is going to be x times vx dx, and that's equal to x squared. Now, if y is v times x, y squared is going to be v squared x squared. And then dy, which is x dv plus v dx. So on the left side, x times x, that's x squared. So we have v x squared dx. Now on the right side, I'm going to factor out x squared from those two terms. So I'm left with 1 minus v squared, and I still have everything else, x dv plus v dx. And let me just get rid of this this is a different expression, not part of this one. So I just want to move that away so that there's no confusion. Now I could divide both sides by x squared, getting rid of this term. So on the left, I just have v dx. On the right side, we need to FOIL. So first we have 1 times x dv, so that's going to be x dv, and then 1 times v dx, so v dx, and then it's negative v squared times x dv, so negative x v squared dv, and then negative v squared times v dx, so that's going to be negative v to the third power dx. So notice that these two terms are identical. So subtracting both sides by v dx, they can be canceled. Now what I'm going to do is take this term, move it to this side. So on the left side, I have positive v to the third dx. On the right side, I can factor out an x dv. So if I take out x first, I'm going to be left over with 1 minus v squared, and I have to take out dv, but I'm going to write it at the end. So I took out x dv from this term, which leaves a 1, and taken out from this term, it leaves behind negative v squared. Now I'm going to rewrite what I have at the top. So that's v to the third dx. It's equal to x times 1 minus v squared dv. So at this point, we need to separate the variables. So we need to put x on one side and v on the other. So I'm going to divide both sides by v to the third, and at the same time, I'm going to divide it by x. So on the left side, v to the third will cancel, and on the right side, x will cancel. So on the left, I have 1 over x dx, and on the right, that's equal to 1 minus v squared divided by v to the third dv. So at this point, we can take the integral of both sides. Now, on the right, we need to separate it into two integrals. 1 divided by v to the third, so we have the integral of 1 over v to the third dv, and then minus v squared over v to the third. So that's going to be the integral of 1 over v dv. So let's focus on this integral first. We need to rewrite it. We need to move v to the third from the bottom to the top. So this is the integral of v to the negative 3. And using the power rule, we're going to add 1 to negative 3. So negative 3 plus 1 is negative 2, and then divide by that result. Now I'm going to bring v back to the bottom. So it's negative 1 over 2v squared. Now the antiderivative of 1 over x is ln x. And this we said it's negative 1 over 2v squared. And the antiderivative of 1 over v is going to be the natural log of v, and then plus c. So right now we need an absolute value in front of x and v. Now let me delete a few things to make more room. So at this point, we're going to replace v with y over x. Keep in mind, y is v times x. So v is y over x. So we have the natural log of x, and that's equal to negative 1 over 2 times y over x squared. And then minus ln v, and that's ln y over x plus c. So this is going to be y squared divided by x squared. Now, recall that we said ln a plus ln b is ln a times b. So ln a minus ln b is going to be ln a divided by b. So therefore, we can replace ln y over x with ln y minus ln x, which is what we're going to do in the next step. So this is going to be minus, and then ln y minus ln x, and then plus c. Now for this fraction, let's multiply the top and the bottom by x squared, so we can simplify this complex fraction. So right now we have ln x, that's equal to negative x squared divided by 2y squared. And now we need to distribute the negative sign, so it's a negative ln y plus ln x plus the constant c. At this point, we can subtract both sides by ln x. If we do, these terms will cancel. And so right now we have 0 is equal to negative x squared over 2y squared minus ln y plus c. Now I'm going to take ln y, move it to this side. So it's going to be positive on the left side. So ln y is equal to negative x squared over 2y squared plus c. Now what I'm going to do is put everything on the exponent of e. So on the left side it's going to be e to the ln y. On the right side it's e to negative x squared over 2y squared plus c. Now e raised to the ln y, the e's will cancel, and for the most part we're just going to get y. Now on the right side, we have two terms that are added on the exponent of e. Now for instance, let's say if we have x to the 5. 5 is 2 plus 3. And we know that x to the 5 is x squared times x cubed. So what I can do is take this and split it into two parts, which is what I'm going to do with e, since there's a plus sign between the c and the negative x squared plus over 2y squared. So I can write it as e to the negative x squared divided by 2y squared times, there's a multiplication here, e to the c. Now e to the c, a number raised to a number, that's a constant. So I could just replace that whole thing with c. And I'm going to move that to the front. So the final answer for this problem is y is equal to c. Let me rewrite that here. I need more space. And then times e raised to the negative x squared over 2y squared. So that's the final solution for this homogeneous differential equation. That's the answer. Let's work on another problem. So let's say that y prime is 2x e raised to the negative y over x plus y divided by x. And let's say we're given a point 1, comma 0. So we got to find the value for c. So go ahead and solve this differential equation. Now every term is to the first degree, and this exponential part of this term is, it doesn't matter, so to speak. It's not counted. So this is a homogeneous differential equation. We can use the same process to integrate it. So what we're going to do first is replace y prime with dy over dx. And let's cross multiply. So we're going to have x times dy on the left side, and then on the right side it's going to be 2x e raised to the negative y over x plus y, and then times dx. So as always, we're going to replace y with v times x. So dy is going to be x dv plus v dx. Now let's replace dy with this expression, and then everywhere we see a y variable, here and here, we're going to replace it with v times x. So this is going to be x times x dv plus v dx, and that's equal to 2x e raised to the negative vx divided by x, and plus another vx dx. So on the left side, I'm just going to rewrite what I have. On the right side, notice that I can factor out an x, and at the same time, this x variable will cancel. So I'm going to have x times 2e to the negative v plus v times dx. So at this point, I could divide both sides by x. So on the left side, I'm left with x dv plus v dx, and that's equal to 2e to the negative v. Well, I'm going to distribute dx to these two terms. So this is going to be 2e to the negative v dx, and then plus v dx. So notice that these two terms are the same. So if I subtract both sides by v dx, they will cancel. And so I'm left with x dv, and that's equal to 2e negative v dx. At this point, we need to separate the variables. So let's divide both sides by x, and at the same time by 2e to the negative v. So we could cancel 2e to the negative v on the right side, and on the left we can cancel x. So on the left side I have 1 divided by 2e negative v dv, and on the right side I have 1 over x dx. So now what I need to do is move the e to the top to make the negative exponent positive. So I have e, let me change the color, so e to the positive v divided by 2 dv, and that's equal to 1 over x dx. So now I could take the integral of both sides. So I'm going to move this constant to the front. So I have 1/2 the integral of e to the v dv, and that's equal to the integral of 1 over x dx. The antiderivative of e to the v is just e to the v, but times 1/2 in this case. And the antiderivative of 1 over x is ln x plus c. So now we said that y is equal to vx. So v is y divided by x. So this is going to be e raised to the y over x. And that's equal to ln x plus c. So at this point, I'm going to multiply both sides by 2. 2 times 1/2 is 1. So on the left side, I just have e raised to the y over x. And on the right side, I'm going to have 2 ln x plus 2c. Now for 2 ln x, I'm going to move the 2 to the exponent of x. So it's going to be e to the y over x, and that's equal to ln x squared. X squared is always positive, so I no longer need the absolute value symbol. And 2c is a constant, so I can replace that with c. And so this is the general equation, or the general solution of the differential equation. So e raised to the y over x is equal to ln x squared plus c. Now, the only thing that's left for me to do is to calculate the value of c. Now, recall that we have the initial value, or the initial point, 1, 0, which means that when x is 1, y is 0. So let's plug in x and y. This is going to be e to the 0 divided by 1, and that's equal to ln 1 squared plus c. 0 divided by 1 is 0, and 1 squared is 1. E to the 0 is 1, ln 1 is 0, so we could see that c is equal to 1. So now that we have the value of c, we can write the final answer. So we could say that e raised to the y divided by x is equal to ln x squared plus 1. Or we can write that like this. It's equal to 1 plus ln x squared. And so this is the final answer. That's all we need to do in this problem. So that's it for this video. Now you know how to solve a homogeneous differential equation.